Hello, my name is Colin Schweikel. I'm going to be presenting to you today my urban design framework plan for the Central Waterfront District of San Francisco. It's entitled Green Gray. This focuses on inland flooding and sea level rise adaptation at two different scales and is implemented by actually augmenting existing gray infrastructure stormwater management systems, enabling them to continue to function without major upsizing modifications through green infrastructure implementation. This also could potentially create social amenities and cultural amenities for different areas around these implementation sites. First, looking at the stormwater surface flow coming off of these two watersheds. So you have the Channel watershed to the north in blue and the Azeles Creek watershed to the south in orange, both affecting the Central Waterfront District, which is between these two channels. The Mission Creek Channel, during a 1,000-year 24-hour storm event, has a discharge rate over surface flow of 81.5 acre-feet. And the Azeles Creek Channel in orange, coming off that other watershed to the south of the site, has a discharge during a 1,000-year 24-hour storm event of surface flow at 232.0 acre-feet. So there's a lot of water even just coming off these impermeable surfaces and escaping, actually getting taken into the gray infrastructure system that's already existing, that get discharged out of these points just due to the fact that they are the historic discharge points as well as they are the low points of topography. So also looking at combined sewer discharge, because we have a gray infrastructure system that's oversaturated and overworked, you do have a lot of discharge events. And two of the primary discharge points on the eastern side of the peninsula around downtown are the Mission Creek and Azeles Creek Channel. You can see them on the left in this small chart. On the far left, you see the Mission Creek Channel in the blown up bubble. On the right in the diagram, you can see these discharge points 22 through 28 are all included in that Mission Creek Channel discharge area. And that, during a 1,000-year 24-hour design storm event, has a discharge of 1,137.6 acre-feet, substantially more than the surface flow, and much the same for the Azeles Creek Channel, but slightly larger, just like the surface flow. You can see the other peak on the chart to the left. That is discharge points 31 through 35, which are all located in the Azeles Creek Channel. And during a 1,000-year 24-hour design storm event, this has a discharge of around 1,621.7 acre-feet. So through the surface flow and combined sewer discharge, these points have a very substantial amount of water that are actually being released there, so they make them key points where you could put in some sort of an intervention that would reduce the flooding, and they also make them key points where you could potentially put some sort of an intervention in to actually treat that discharge that's coming out before it enters the environment, hopefully. So an initial stage is just to address the inland flooding concerns and accept the sea level rise. So on the top right here, you can see the 24-inch sea level rise 500-year design storm flooding projection. This was unofficially given to us by the San Francisco Public Works Department. In these different areas, you can see a shape block area that is used to represent the green infrastructure and green corridor areas that could be put in to address this inland flooding based on those charts on the upper right. In those charts, they're different colors to show different projected flooding inland. So blue, anything in blue there is a 1 foot depth inland flooding. Green is 2 feet, yellow is 3 feet, and red is 5 feet or more. So in those areas where you have the yellow and red, those are key concern areas where you want to put some sort of a intervention and allow it to be a floodable space. Also, in thinking about how you can size these different areas, if you were able to increase the amount of time it takes water to enter these spaces and go through these spaces, you would actually decrease the amount of catchment area you would need during a storm event. So implementing smaller scale stormwater capture, much like water parks that you can see there at decreasing elevations from the top of any sort of a catchment area, would actually slow down and retain the amount of water that's going in at any given time, reducing the required catchment size for these green infrastructure interventions. You can also do this through implementing wide-scale hydroponic green streets that would hold water and slow it down. And also, if we're assuming that we're going to adapt to this 24-inch sea level rise or greater, something like a Blue Parkway Canal or a way to let seawater come in at points of least resistance along the existing shoreline is also something we might want to look into. So another dimension to this is transit. We have a whole lot of people moving around and having to get into downtown through this area. You have the BART, which is the Bay Area Regional Trail. You have Muni Metro, which is more localized rail transit. And then you also have the U.S. Railway line that comes in right around the southern end of the Mission Creek Channel and then lets everyone off, I believe, 2 blocks into downtown from the channel. So you have hundreds of thousands of people commuting into downtown every day through public transit. And on the right, you can see that we also have a lot of people cycling into town for their commute, and this does involve a lot of people getting injured or killed in vehicle collisions. So right here you can see a lot of the high traffic corridors are in that area near where you have Division Street connecting, where you can see the BART line and the edge of the U.S. Railway, as well as you also have a high traffic corridor with a lot of accidents along where the Muni Metro line in orange actually converges with the BART Railway on the left. So anything that's an X here, you can see someone severely injured and that was most likely hospitalized. Any of the darker lines that represent roads are something like 16 to 29 injuries recorded, and then anything where it's cross skull and crossbones is going to be a death. So as you can see, there's a lot of injuries right now, and possibly establishing a new transit corridor that would be part of a greenway would create a path of least resistance for a lot of these cyclists and transit commuters, and hopefully reduce some of those injuries and deaths. So looking at first the inland flooding adaptations that we showed, and then we'll go into a larger scale in a second. A interesting connection that could be made is bringing that junction between the Muni Metro and the BART on the left and taking a new Muni line down through Division Street and that lowered Highway 101 area in a greenway, and bringing that into another transit hub where the U.S. Railway comes close to connecting with the other Muni Metro, and then also using that converted Highway 280 corridor going down from the Mission Creek Channel and the U.S. Railway drop-off area down to the Azales Creek Channel as another Muni Metro option, where it could be another loop going through Dogpatch and also having it closer to Potrero Hill, giving people more access. And also potentially around that Azales Creek Channel, due to the relative open space and potential for more open space, you could have maybe a transit center or a park and ride, allowing for more people to choose to do regional transit and or biking from that location instead of having more traffic and parking going into downtown. So on your bottom right here, you can see some sort of a conceptual component layout of how you could put together these green spaces. You could still have a reduced size roadway, allowing for vehicles to still get through and do their day-to-day because you still have to have access. But you could also have increased bike and pedestrian walkways. You could have your daylighted channels, which would be variable size depending on the flooding need and depending on the actual size of the greenway. You could have regional trails on the inside, making it feel more comfortable for people to go jogging or just have exercise outside. And then you could also have local transit, and that could be either along the roadway or inside. In this, it was just conceptually shown inside to show that it could be in both locations. And then, as you can see with these arrows, all of these components could have some sort of a stormwater conduit capability that would retain it and slow it down. And now looking at the larger scale intervention that could be implemented on the site, which would be a super levee. This could combat sea level rise for the next 200 years, as well as potentially treat the combined sewage that's discharging during large storm events and the surface flow that's coming off of these different watersheds and discharging at the Azales Creek and Mission Creek channels. So this levee could encompass those two channels and actually contain that space, providing an opportunity to have some sort of a treatment area between the existing shoreline and the super levee This could involve some sort of a living machine subsurface treatment for the combined sewage discharge, a tidal marsh system, or an oyster reef, or a combination of all of the three. And this could treat the combined sewage discharge as well as the surface flow runoff that would be contaminated with heavy metals and other pollutants, as well as potentially have a year-round capability to treat combined sewage, much like the Southeast Treatment Plant. And this would be able to reduce a substantial amount of stress from the existing gray water system. Now looking at the super levee, you could potentially have some developments on the inside of the super levee or the outside, and that could be an economic driver for the project. You could also have a nature area on the outside that would allow for a wave break, so it would be a shallower slope going farther out. It would undercut any major storm surges that are coming in. And it could potentially also provide a really unique natural amenity for this very dense urban environment. And then in the top right, you can see some sort of the integration of a transit loop that would go onto the super levee, allowing people to get out to those different nature areas, get out to the super levee, and potentially also create another loop that might be able to get people out of the city faster and down to the Hunters Point area. So that is my presentation proposal. Thank you very much for listening. If you have any questions or comments, please leave them below. Thanks.